Here we have another way of calculating the area of a triangle called Heron's formula. I've heard different pronunciations. And this is going to allow us to calculate the area of a triangle, of an oblique triangle, for the side, side, side situation. And the reason I have the law of cosines title on it is because this formula is built upon the area formula that involved the sine function, which was built off of the law of cosine. So it's just kind of a 2 steps away from the law of cosines. But this formula, Heron's formula, is area equals, and it starts with, it's got this big long square root symbol, and the first thing we have there is an S times S minus A times S minus B times S minus C. And this allows us to calculate the area of a triangle without having to know any angles. We don't have to use the height. We don't have to do anything. It's just a straight side, side, side. And this we can use with our oblique triangles. Now, A, B, and C are our side lengths of the triangle as usual, but S needs a little secondary definition in here, where S is equal to half of A plus B plus C. So when we have that, or we could say this is a 1/2 of the perimeter of the triangle. When we have this, we can use we don't need any angles. Side, 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 oblique triangle, no right angles. We can just go ahead and pop the values in there, and we get that. And this is derived from the law of cosines as well. Although there are no trig functions in it, we know this works. Its proof is built off the law of cosines. So let's just take a quick look example, because it's really just using the formula here. Oops, I got a spelling error there. A triangular field has sides of 125 yards, which I guess is yards, and I must have done some cutting and pasting. 160 yards and 225 yards. Approximate the number of acres in the field. So a 2-step process here. 1, find the area of the triangle in square yards, and then perform a unit conversion to turn this into acres, which is how land measurement for ownership is typically measured. So our formulas here, so let's go ahead and calculate S first. We're going to have half of 125 plus 160 plus 225. So that's going to be half of, I would probably take the 125 and the 225 and add them together in my head first, and that's going to give us 350 plus 160. So that's going to be half of 510, I believe, which would be 255. So we're going to use 255 as the value for our S. And so then this would become, our area formula is going to be the square root of 255 times 255 minus 125, 255 minus 160, and 255 minus 225. And we just a matter of kind of popping that into the calculator, not a big deal, and we end up getting 9,720. Now, these are still our yards measurements, so 9,720 square yards. The question was acres, so time for our unit conversion piece, so we'll just take 9,720. Oh, and let's see, let's scroll up here. Our problem said there are 4,840 square yards in 1 acre, so that's 4,840. So I can just come down here, 4,840 square yards. Do a little division here, put it in there, and we get that it's just about approximately 2 acres. I don't know what the abbreviation for acres is, so I'm just gonna write it. So 2 acres. Mostly just, hey, we got this formula, we can use it. Heron's formula for the side scenario of finding areas of oblique triangles, and it's pretty quick, pretty fast, matter of using the calculator. Hopefully you'll be able to use it well whenever it comes up for any of your questions.